Okay, we're going to do question 8, start of geometry of this 2020 supplementary paper. 8.1 is proving the tan-chord theorem, and that's just in your textbook. There's other versions of it that you can get. There's more than one proof. You just have to learn it. But at question 8.2, first it tells you that PWRS is a cyclic quadrilateral, and PSW is an equal. That's important. PSW is an equilateral triangle. All the sides are equal and all the angles are equal, which means they're 60 degrees. TW is tangent. TW, there's a T down there. TW is tangent to the circle at W. The radii are OR and OW are drawn, and W5 is 25 degrees. Okay, let's try it. What's angle S1? Well, it's written out on the other side, and I'll show you. You have to write this out properly. You have to say, hey, S1 I know is 25 degrees because, and then you have to write tan-chord theorem, because the angle between the tangent and the chord equals the angle that subtends that same chord, the angle in the alternate segment. So that angle, 25 degrees, equals the angle at the top of the triangle, 25 degrees, tan-chord theorem. O1, well, this is an angle at the circumference, and this is an angle at the center, and the angle at the center is 2 times the angle at the circumference. So you say O1 is 50 degrees for another 2 marks, because the angle at the center is twice the angle at the circumference. Now they say determine R1. Ooh, that's going to take a little bit more work. Now these 2 guys are radii. That means that these 2 angles have to be the same, and because it has to add up to a triangle, if you go 180 degrees minus 50, and then you split it into 2, those 2 angles right there, angle W3 and W4 together, and R2 must be 65 degrees because of equal angles opposite equal radii, equal sides. Okay, there's all of those questions on 8 marks. Now they want you to prove that SP is parallel to TW. Well, you know some, we have to figure out R1. Sorry, we're going to figure out R1. Well, this is an equilateral triangle. That means all the angles in triangle PSW are 60 degrees. That means angle P is 60 degrees because it's an equilateral triangle. Oh, and we know that these 2 are 65. Oh, we were trying to figure out R1. We actually needed all of that because now that we know that's 65 and that's 60, angle P and R1 and R2 are the opposite angles of a cyclic quad. They have to add up to 180. So if we go 180 minus 60 plus 65, that means angle R1 is 55 degrees because of the opposite angles in a cyclic quad being supplementary. Okay, that's all of those reasons. Sorry, I figured out those 2 are 65 because of equal angles opposite equal radii. That's 60 degrees because it's an equilateral triangle. And then finally, R1 must be 55 because these opposite angles in a cyclic quad have to add to 180. Now we've got to prove that SP is parallel to TW. Well, hey, we knew that this was 60 degrees too, because S2 and P and this other angle down here are 60 degrees. But hey, look at this. This angle in here, W1, must equal this angle. S2 must equal 60 degrees because it's an equilateral triangle. W1 must equal 60 degrees because, oh, that's the angle between a tangent and a chord, the tan-chord theorem. And then that means these 2 lines must be parallel because their alternate angles are equal to 60, both equal to 60 degrees. They're equal. And that makes these lines SP and TW parallel. And when you write it all out, here it is in the memo, all done. S1 25, tan-chord theorem, O1 50, angle at the center, 2 times angle at the circumference. R2 equals the W3 plus W4, 65 degrees, equal angles opposite equal radii. P is 60 degrees because it's an equilateral triangle, And R1 is 55 because of the opposite angle of a cyclic quad being supplementary. We know that W1 and S2 are 60 degrees because of the tan chord theorem. And we knew that S2 was 60 because of equilateral triangle. Well, therefore, W1 equals P. They both equal 60 degrees. Therefore, SP is parallel to DW because alternate angles are equal. And there's question 8.2 done. Okay.